Hi, Chinmay, good morning.
Yeah, morning. Hey, there are 15 people. Can we wait for another 2 minutes? Just wait another 2 minutes. We'll start.
Okay.
It seems this number is not going to increase. So I think we should start. Any question, any concern which you have, which you want to discuss with me regarding your previous class? I hope you all received recording files and all the data files.
Yes, Chinmay, we received it.
Perfect. So we completed statistics fundamental 1 and fundamental 2. And now from there, it is time to jump to the statistics part and perform something called EDA, that is exploratory data analysis. So we are going to start a new chapter. I hope in the previous class I finished everything. Just have a quick recheck. In statistics fundamental 2, we discuss about ANOVA, and finally we validated all these numbers. I suggested you people to try to do this calculation by your own. Did anyone get chance to do it? If you try, you will be getting the same answer the way it is given here, and follow the same way, the way we followed in Excel. I think that is what will be the helpful.
Yes, Chinmay, regarding this, as I was practicing, I wanted to ask you whether we need to know advanced Excel while in this course
No, 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 no,
as an
no,
extra part.
no. So I would say that
Advanced Excel is not required.
in data science, usually we use Excel to very less extent. So there is no requirement of Excel.
Okay. No. Actually, why I asked you this is because in our Amazon we have an internal job portal. Okay.
Mhm.
So I was looking through some of the positions that I can apply for afterwards. So there are many of the job positions it was written that Excel is mandatory along with Tableau or Power BI and some scripting in Python and R. The first requirement was Excel. That's why I asked you that whether it is required for us or not.
I would say in data science in general, Excel is not required, but there are certain companies they are particular about some Excel skill. So if you are planning for those organizations, so you need to develop your Excel skill as well.
Develop those.
Yeah, if that is, but this is
Okay.
not
Okay.
this is not a kind of hard and fast that we need to have it. But yes, as you are saying that in your case, it is more like they are uh, mentioning for the skill, Excel skill.
Yes.
Yeah. So in that case, you should have.
Okay. Thank you.
Any other question? Okay, if there is no question, then we are moving to the next part, and we'll see that how essentially we answer certain questions. Okay, that's fine. So let me close this one. Now we are moving to EDA, that is exploratory data analysis. Okay, that is what your technically the first step is when we talk about the data science work. So whenever you get some data, it is expected that we perform some kind of exploratory data analysis and see that how the output is coming. So that's what the agenda here is, to do some initial data understanding and then come up with our own thought process that how data is looking like, etc. I hope that is clear. That's what the role of EDA is, that is exploratory data analysis.
Okay.
So it helps us to, as name is suggesting, that it is explore. So we try to explore the data, and how the exploration happen by help of the graph, or we perform certain tasks. We'll talk about those functions, that how does it work. But yes, this is what the role of the EDA is, that is your exploratory data analysis. Got it? Now,
Sir, is that basically the pre-processing of the data?
you can say, yes, you can say that this is technically this is pre-processing of the data. You can say it.
It means that we need to organize the data into particular categories so that we can find the meaningful insights from it.
You will see that what all we do. Getting it? So that is one thing, but there are many other things which we do here in EDA. Got it? Now,
Got it, sir. Yeah.
so here we are going to talk about some EDA process. That is, we are going to talk that what is exploratory data analysis, what are the processes involved in this, and how do we handle different data types accordingly. So it so happened that in your data, your data types comes in a different way. Getting it? So in that case, we need to deal it, or we need to tackle it differently. Okay. So this is the analytics life cycle is fine. So what happened that the moment we get some data, it's saying that how the approach for exploratory data analysis is EDA is that you need to analyze and explore the data visually and statistically. So that is the important thing that we need to remember, that here whatever we try to understand by help of visual, as well as we try to do something by help of statistical way as well. Getting it? Now, then saying that, then we summarize the main characteristics, that what is the different behavior of the data is there, then identify the potential informations the data offers, that what all information coming from there, and then formulate the hypothesis that lead us to find something new or something meaningful. I think that is how the entire process is for as far as the EDA etc. is concerned. Now, then we are going to this approach. This graph is important to understand. There are multiple reasons for that. The first is you will come to know that where is the EDA helpful, and in which context we can take it up. So it is saying here that we collect the raw data. I will first explain the graph, then you will understand that what all write-up is given. It is saying that we need to first collect the raw data. That raw data is coming from anywhere. Then we need to do the then data is going in the processing phase. That means you are going to process your data, and the moment I'm saying about the processing the data, so that processing involves some cleaning of the data sets as well. Cleaning that means outlier treatment, missing value treatment, lot many things happen. And once your data is clean, then you perform exploratory data analysis, EDA, and see that how your data is looking. Now, post EDA, when you realize that no, something is missing or I need to do something differently, then you need to again do the data processing, then again clean the data and do the EDA. So EDA is like, it helps us to estimate or understand that your data is, what all processing you are doing, that's the proper or that is not the proper. Is that fine for the next level of analysis or that is not fine for the next level of analysis? I hope that is clear.
Yes, yes.
Now, this is how the role of the EDA is. So look here, EDA we do, if you look here, it is looking like circle. It is moving, going, the way it is coming. Okay. Now, once that EDA is done, then I would say there is another connecting element which says that this one. I would essentially connect this EDA, this one. If I connect it, it is not the bad habit or not the bad idea. So once your data is fine and you realize that this is ready for the next level of analysis, then you models your data and start doing the model building activity. And then you realize that your model is proper, then you communicate the result, and accordingly the end user or the stakeholder, whoever is there, they consume the data. I hope that is fine.
Yeah.
And
Yes.
so like you are communicating the result, etc. And if possible, you are making the data product, or it's all depend that you are sharing the result or you're making the data product. The moment I say data product app, let's say that in app, you are feeding some information and you are getting some output. So that app is called a data product. So you're making some product out of your data. Getting it? That's a solution. Data product, that is the technical name of solution providing. The way we provide the solution, people call it data product. I hope that is fine. The entire process. Now you read the lines which are given here. You can easily understand that what all written. I hope this is fine.
Yes.
Okay. Now from there, we are going to talk about something called sample and population. So listen.
Sir,
Yeah.
hello.
Yeah. Tell me.
Hello. Sir, in that before slide, second statement I could not understand here. It's often the first step of data analysis implemented before any formal statistical technique are applied.
Okay.
So is this a EDA or something else?
It's EDA. It's thing for the EDA only. So understand there are.
I mean here after 3 stages we are coming back, right? After raw data collected, data processed, data cleaning, in between then exploratory. I mean to say like EDA will come.
I say that EDA happens at the any stage. You see here that you are doing some EDA and you realize that your data is not in proper shape. So again you are coming back to data processing. So it is a loop. Getting it? It's a
okay.
It's in a.
I mean to say like here data process will happen in the first stage of the process, right?
So data processing and data cleaning, these are all considered part of EDA. Got it? So the moment
one more question, sir.
Yeah.
Okay. Process means data is processed.
Data processed means, let's say that you are getting data from multiple sources. Okay. One source is talking about the employee organization level information like hierarchy, then designation, team, etc. And other is payroll level information. Getting it? Which is with the HR. So let's say that you are getting data from multiple sources. You need to process the data to bring all together. wherein because one data is having employee level information, other data is having salary level information. Getting it?
Okay.
So we are bringing
So
together.
we have to make, okay, we have to make an alignment. One is purely data related to salary. Other one is the name wise, like that. We have to make it an alignment.
Correct. That is one example of data processing.
Okay. And cleaning means unnecessary things. We will clean the thing.
All right.
Okay.
So EDA is a part of like it's a kind of to understand some data before processing any algorithm, any function. Like
So it so happened that
right?
EDA is your first step. Okay, that's how good your data is. I'm telling you, you think from this perspective, other than data science, that will give you a very clear picture. Let's say that you are planning
How
to.
we understand the data.
It is to better understand the data.
Yeah.
It's all about understanding the data. Let's say that you are going to make a building, getting it, and for making that building, you are getting the resources from many vendors. Someone is supplying you the iron rod, someone is supplying cement, someone is giving others bricks, everything. Got it? Now you got item from every person. That's what the raw data collected. So you collected the raw materials from everyone. That's what the first step is. It's clear. You collected the data. Fine. Now
It will be stages will be there, sir, for this raw data collecting.
yeah.
The particular stages will be included in that. Like if we are collecting the steels or raw someone, the stage of execution time only we will collect the this one raw everything.
So it is first we collect the raw data. Okay.
Okay.
Now let's say that you got bricks from multiple vendors because you are going to make a very big construction site. And now then you are putting all bricks together and then getting that which all bricks are broken. That's what cleaning the data set. So you are cleaning, you are removing those broken parts. Got it?
Okay.
That activity which I explained, that only say for bricks. The similarly you are going to do for the sand. Getting it?
Okay.
Cleaning. Once everything is cleaned, then as a expert you are looking that is my inventory proper? Should I go for the next step? That is, should I go for the construction? Because before you start the construction, you need to get these all raw materials. Got it? Now, the stage where you decide to go for the next step, and there you are doing some understanding, developing understanding like that. Do I have sufficient raw material? Do I have sufficient bricks? Do I have sufficient sands? Do I have sufficient cements? That is what we call exploratory data analysis. So that is the stage wherein you decide that should I go ahead or I need to do something else. Getting it? That's why it is saying that the moment you are here and you are getting that you do not have the sufficient raw material, you are again going back and you are doing the entire process. You will do this process till the time you do not figure out that now you have the sufficient stuff to move for the second stage.
EDA itself is a philosophy.
It's the first step of data analysis.
Okay.
I hope now it is clear.
Clear.
Now,
Is EDA and ETL the same?
ETL is different stuff. ETA is before EDA. That is, ETA is extraction, transformation, and loading. So the data extraction which we are doing, collecting the data, that is what people call ETL.
Okay.
Now, then, guys, I'm getting some background noise. People can mute yourself. That will be helpful. Now, then, if you remember, I explained about sample and population. So can someone summarize me about sample and population? I just wanted to know the understanding. That do you understand what is sample, what is population?
So sample is okay. Go ahead.
Yeah, go ahead.
So population is something which is widely followed a trend, let's say all bulb trends, all life of bulb trends across the globe. Then taking your bulb samples from your, taking a random sample of bulbs from your kitty is something which is sample. So population is very huge. A sample is taken a certain quantity from the population.
That's perfect. So now that's how we define sample and population. So population is the whole mass which is of your interest. Let's say that someone is saying that, can you tell me what is the average salary of people staying in Bangalore? So Bangalore, the entire working professional of Bangalore is population. Now then you are saying that no, I cannot connect to each and every person to get their salary information. What my plan is that let's have a sample of some people, some from the North Karnataka, some from West, some from East, some from South, and you are getting some samples. So from each regions of Karnataka, you are getting the the samples, and those samples are small with respect to the entire population. And the moment you are getting the information, so look here, what it's saying that this is your entire population where my cursor is, and from this population you selected some sample. This is what the sample is. So some sample is subset of the population, and on that sample you are running some exploratory data analysis. Got it here. And now this is what your data is. The data you are getting, is your sample data. In data science, whatever we get, that is always a sample, that is never a population. Like if someone is saying that, can you develop a default model of a particular bank? So yes, default that particular bank customers are sample with respect to the entire universe. I hope you are getting what I'm saying. So here it is saying that the moment from the population we get some data, that's called sample, and on that sample we need to perform certain tasks. We need to develop our understanding, and once we develop our understanding, then we generalize for the population. What does it mean, generalization? Let's say that you got 100 sample from Bangalore, and objective is to figure out that what is the average salary of people staying in Bangalore. Got it? In Bangalore, let's say that there are 70,000 professionals in Bangalore. I'm just giving a number. 70,000 professionals in Bangalore. Out of that, you got sample of 100 people. And for those 100, you generated certain numbers like what is average salary, what is maximum salary, what is minimum salary, etc. Fine. And by help of those 100 samples, you are going to generalize for the population. Now you can say that though my sample is looking like this, so I'm presuming that my population is also having the similar behavior. Clear? That is called the inference. So what all information we get from the sample, we need to generalize that for the population. I hope that is clear.
Ajay, can you explain the last line which you generalizing thing?
Okay, so now listen very carefully. Let's say that there is a big river, okay, and in that river, someone is saying that, can you tell me, just a moment, guy. So I was facing some laptop issue, so I raised a ticket with Dell, and I thought the Dell guys are calling. These people are so precious. If you miss their one call, you need to follow them multiple times. So I was explaining about that sample and population, and I was giving example of river. Let's say that there is a big river, and you someone is saying that, can you tell me that what is the number of fish in a 1 kilometer radius, or in a not 1 kilometer radius, in 1 kilometer length? So listen this very carefully, that will give you the clear idea. So now the question, someone is saying that, can you tell me that how many fishes are there in 1 kilometer of the length of the river? So my problem statement is clear?
Yeah.
Now, then what are you doing? First of all, you cannot count all the fish in 1 kilometer length. So you are putting some net in a small area, let's say of 20 feet radius. You are putting a small net, and in that net you catch some fish. And you are saying that in that 20 feet radius, these are the number of fishes which I catch. Okay, so that you are giving about the sample. So you got from sample. Okay, and now
Hmm.
you are assuming that this sample which you got from the river is homogeneous everywhere. You will be getting the similar quantity of similar distribution of fishes, the way it is visible. Can you see the dots are equally distributed? Got it? In the in the blue one, are you getting these dots are equally distributed?
Yeah.
That's what our understanding is, that in the river fishes are distributed homogeneously. Now then you got that in a 20 feet radius, let's say that you got 100 kg of fish. So you are generalizing, saying that in the whole river, if you are going to consider anywhere the 20 feet of the radius, you will be getting 100 kg of the fish. That's what we generalize. If someone is saying, okay, that is a scenario, can you tell me that in 100 feet of the radius, how many I will get? So you know that in 20 feet of the radius, you got some, let's say 100 kg. So in 100 feet of the radius, you will be getting some, let's say some 500 kg of the fish. That's how we try to generalize.
Okay.
Got it?
Sir, inference
Chinmay,
means it will be.
Chinmay,
Yeah.
I have a question. So till now, all the distribution we were doing the reverse. We had the population mean, and then we are inferring something about the random sample. Here it is the reverse. It just looks like the reverse thing. Is it like? Did I
Yes.
get it correctly?
Yes. So it so happened that in real life, we never touch all the population. We always touch the sample only. Touching the population is, first of all, very big cost. If someone says that, can you calculate that what is the average income of people staying in Bangalore? We can do that, is doable. But do you think how big cost it involves and how big duration it is going to have?
Correct. So here we don't have information about the population mean. So we
Yes.
generalizing from the random.
Correct.
Okay.
So the moment we do not have information about the population, we try to generalize by help of the sample.
Okay. Cool.
Is there any other question?
Inference means predictions, right?
Inference means generalization, not prediction.
Yeah. Generalized.
Yes. Some statement you are going to say. The way I mentioned that in 100 feet of the radius, you are going to get 500 kg fish. So we are generalizing it.
Okay.
So in that fish example, after the data, probability and inference there. So can you explain in that example?
Now, then
Can you
coming
continue
to,
that example?
so let's say that you are, first of all, you are getting some data. And on that basis of data, you are performing some task. Why probability is saying here? Probability is talking about a normal distribution. The way I mentioned that your data is completely homogeneous. That means that is indicator of the normally distributed something. So this probability is talking about a normal distribution, nothing else.
Fine.
Got it?
Yeah.
Now, then I am moving to the next slide. Now, so these are the certain techniques which involve into performing this EDA. The first is univariate analysis. So the name itself is suggesting uni means one. and variate means variable. Those analysis which involves on a single variable. So can you tell me that which all analysis are there on the single variable? Do you remember any analysis which we do on the single variable, on one variable only?
So that normal distribution in the whole, that is uninormal. I think binomial is a different one.
Anything else you remember?
Bar graph we do on a single variable.
You people are giving big answer. I'm expecting very basic answer. Univariate analysis. Example of univariate analysis.
Sir, considering the types of population in one city, if it is male or female.
Is it one way, ANOVA?
No, it is not one way ANOVA.
We have one tail, two tail hypothesis.
It's not so. Univariate, your mean, median, mode, variance, everything is univariate, man.
So we have one tail hypothesis.
It's not one tail, two tail. The moment I'm saying one tail, two tail is, which is again, this is part of the univariate analysis. It goes to the next level. The moment I say univariate, I just wanted to know that in which all analysis we involve a single variable. Mean we do on a single variable, mean, median, mode, variance, skewness, kurtosis, everything we saw that was on univariate only. A single variable. Got it?
Okay.
Now, then coming to visualization. So yes, we try to visualize the stuff. Let me move from univariate to write this bivariate, then I will come to visualization. Then coming to bivariate, the way name is suggesting, bi means two and variate means variable, two variables. So whenever we try to understand or try to figure out by help of two variables, that is called bivariate analysis. Like, so if you are trying to know that what is a relationship between salary and saving, that is what we call bivariate analysis. Got it? So whenever two variables are concerned, that is what we call the bivariate. You remember we plotted in the previous graphics, we plotted something between two variables. So one variable was on the x-axis, other variable was on the y-axis. Got it? That is called the bivariate analysis, wherein two variables are involved. Correlation is one example. There are many other examples. Will we talk?
Height and weight also comes then.
Yes, you can find the relationship between height and weight. Yes, that is bivariate. Then we do the visualization. We'll discuss about this. Then we are going to talk about the handling data types. So the moment you have different types of data, how to handle it. Then there is something called contingency table. I will explain about this contingency table. And correlation plot, feature identification, hypothesis testing. We are going to do one by one to understand that what all comes here. So there are many processes which comes under EDA. People technically ask question about these processes, that what do you mean by univariate? What do you mean by bivariate? Or what is contingency table? So this question comes. So we are going to explore one by one. Now, in that it is important for us to know certain functions. So these are the functions which are technically for coming from. If you remember this int function we discussed about integer. In R, you remember I wrote
Yes,
as dot integer and converted something. Got it?
The types of data in R.
Right. So sometimes it so happens that we need to convert some data type from one form to other form. So let's say that a data is given as numeric, you want to convert that as integer. So there are certain functions. These functions are the Python functions. So I'm not going to explain about these functions because it's too early for us, but we'll find some other equivalent. And one example I suggested that if you write as dot integer and pass your value, it will converting your data into the integer. So likewise, there are many functions we are going to talk, but this slide is coming from the Python coding perspective, not from R. We'll find the equivalent one, that what all are there. Now, then we are going to talk about the univariates. The way I explained that in univariate, what all we discussed in the past, many things are there in the univariate, like mean, median, mode, variance, standard deviation, box plot, histogram. These all comes under univariate. I hope that is clear.
Yeah.
Now, so these are, I would say that univariate some of the functions which we need to know, that if someone is saying that what all univariates are there, you can figure it, you can find it. Any question in this part?
Fine for me, Chinay.
Okay. Perfect. Just a moment. Now, then here some write-up for mean is given. Just go through. I hope you all will understand.
Yes, sure, I understand.
Yes, I hope this is clear. Now, this is for mean. Now, next is given for median. Just go through.
So in the previous slide, how we can calculate the mean of the population, because we have got the sample mean only,
No,
right?
so here we generalize. So if the mean of the sample is coming 18, so we can say that the mean of population is also 18.
Okay. Got it.
Got it? I hope it is clear to everyone. Then coming to median. This is written for median. Just go through. This is fine. This is the same one. I think in past also we had the same content. Correct?
Yeah.
Now, then coming for mode. So here we are taking that what the mode is. The same one, nothing new with respect to the previous one. Now, then we are talking about measure of dispersion. Well, I will quickly move, reason being it is not something which is completely new. We had similar information in past as well. So if you remember the range, I hope you remember it. How range is calculated?
Yes, higher value minus lower value.
Yes, that's how the range is. Then the variance, this is formula for variance, wherein we calculate x minus x bar or x minus mu, square it up, divide by number of records.
Yes.
I hope it is clear to everyone. Now, then coming for standard deviation, this is what the magical number we saw. 1 standard deviation, 2 standard deviation, 3 standard deviation. That's what we saw.
Yeah, 67, 95, and 99.7.
Correct. This is what it's saying, that this is, it is saying that sigma is standard deviation of the population and S is the standard deviation of the sample. So be careful. One is the English letter, another is the Greek letter. Then there is something called coefficient of variation. It's a number. When you divide standard deviation by mean, we got this value, CV, that is coefficient of variation. Clear?
Yeah.
Now, then if you remember the box plot, I explained that we have 5 number summary: maximum, third quarter, median, first quarter, minimum. These are the 5 magical numbers we need to remember. Why I'm calling it magical? Because these are good indicator of your data attribute, about your data behavior. Clear? This is helpful to summarize the data. Now, look at this data, and I'm expecting some expert opinion, because what I'm presuming that after a month of class, you people can understand the data, that how the data is. Look at this example. You have 7 examples, that is 7 rows. Okay, and what do you mean? There are something highlighted in the brown background. Just go through and tell me that what is your understanding about this data. Spend some time and then tell me. Sharmila, we are getting some background noise. Would you please unmute your mic? Yeah. Now look at this 7 records and tell me that what is your understanding? What do you understand about these 7 records?
The Q1 is the maximum value. Hello. In a box plot, for example, if I take as a box plot,
it is not Q1. Here, this Q1 is simply saying, let's say I'm first read the question. What is it? Q1 is question 1, question 2, question 3, question 4. This is not first quarter, second quarter, third quarter.
See, it is like a what do you say? A questionnaire which is given to customer or something like that. That is the 5 questions were given.
Right.
So in that 5 questionnaire, so these are the 3 lines. They are directly given. I think it is directly all the questions they have given the same number 2, 2, 2, 2, or 3 or 4 or something like that.
So mean, median, and both the things are same. I mean to say mean, median, mode. Maybe 3 of them are same in this straight line means.
Okay. So why are we calling it straight line? Reason being, the values are exactly the same. And you remember, I mentioned that statistics is only useful when there is variance. If there is no variance, statistics has no role. Getting it? That's why for respondent 1, 5, 6, it is saying straight line. If it is coming like straight line, that means this data is useless. These 3 records are not going to add any meaning for us. So saying that we remove the straight line in a shortest way. Fine. So if you are getting anything which is coming like straight line, that means all the values are same. It is suggested to remove those records from the analysis. Got it?
Yeah.
All right. Now then I'm coming to the next slide, like here. Did you see that the variance is 0? That means standard deviation is also 0. So for those 3 records, you are getting standard deviation is 0. And that is, getting standard deviation 0 is something which is detrimental for the statistical analysis. I hope that is clear.
Yes, Chinmay. I think in one of the clause you explained that if it is all the things that are same, there is no statistics.
Right. So why I try to reiterate or repeat, reason being there are many people, they may not recall the concept or did not get time to go through the practice. So I need to consider those people as well. Now, look at this data. There are 4 sets of the data given. One set, one is given, 2 sets, second set, third set, and fourth set. And in both the cases, x and y is given. So let's say that x is height and y is weight. You can think like that way. So there are 2 variables, 2 values given, x and y, and you are getting this information from the 4 places. Let's say the first, wherein first is saying it is Delhi, second is saying it's Mumbai, third is saying it's Bangalore, fourth is saying it may be Chennai. Getting it? So from the 4 places, you are getting some records. Let's say the student records, those who are in a class, second class, third class, whatever. And we are getting their height and weights. So first is height and second is weight something. Now, if you look at this data, first of all, looking at this data, we cannot say that are these all 4 behaving in similar way or these 4 are not behaving in similar way. We cannot say in one go. So what we need to do first? We need to calculate mean of x and y in all 4 cases and see that how the means are. That is first thing that we should do. Yes or no?
Yeah. Yeah.
So look at
Yes.
it is calculating mean, saying mean for x in all the 4 cases. So mean in all the 4 cases are 9. Variance in all the 4 cases are 11. Mean of y in all the 4 cases are 7.5. So this is giving the statistics that for all the 4 cases, you are getting very similar information. Mean of x, mean of y, variance of x and variance of y. You are getting like coefficient of determination for the, again, linear regression. You just forget this last 2 lines because that is talking about the linear regression. In the linear regression class, we'll do some deep dive. But what all we discuss, like mean, variance, mean of x, variance of x, mean of y, and variance of y. Just look at these 4 numbers. You are getting it is saying that it is exactly the same. That means there is no difference in the mean and variance of x and y. Does it mean all the 4 set of the data are same? If primarily we look at these numbers, we can say that yes, data seems very similar. That means data is almost the same. We can say. Now, but the problem comes when we go for plotting it. This is the data and we are plotting all 4 sets of the information taking x and y. So on x1 axis, it's your x, on y1 axis, this is y. And we are plotting for these all 4 sets of the information. Now you tell me, do you think that these all 4 are same?
The distribution is different, sir.
Yes.
The way the data is distributed, that is different.
Yes, that means the behavior of the data is different in all 4 cases. I hope that is clear. Is it clear to everyone?
Yes, sir.
Now, then saying that we are going to visualize the univariate data. So for univariate data visualization, we use like histogram, bar chart, box plot, pie chart. We did that in the past. Got it? So these are way to visualize the univariate data. We are just going to recall what all we did. This is how your histogram look like. Clear?
Yes.
Wherein again,
Sir,
yeah.
Univariate data is wherein we have one categorical variable and one numerical variable.
No, it's not. Univariate one. That may be categorical, that may be numeric. A single variable.
Okay.
Let's say that someone is saying that arrival in minutes. How many planes are arriving to a particular airport? Let's say from starting to 12 minutes. So you're saying that in the first minute, some 3 planes came. In the second minute, some 4 plane comes. Got it? So you are making it. So your variable is the arrivals.
Okay.
Got it?
Got it.
And your y-axis is frequency. That's how many those numbers are happening. So yes, in this case, it is a categorical variable, and on top of that, we are doing this frequency.
Okay.
Then next will be your bar chart, and we all know that how the bar chart look like. And bar chart is essentially a kind of histogram, but if you look here, it is plotting in 2003 what was revenue in Q1, Q2, Q3, Q4. So in different quarters, what is the revenue we are getting? Got it?
Yeah.
Now, post bar chart, we have box plot. And I hope you all recall the box plot concept. This is what I talk about, the 5 magical numbers. Clear? Wherein talk about the maximum, third quartile, median, first quartile, and the minimum value.
Yeah, yeah.
Then this is how the pie chart look like. If someone says that, can you tell me the percentage usage of different interface like Chrome, Firefox? I'm talking about the internet browser. So depending on the number, you can plot that. Look how these numbers are. Clear? I think it is very obvious. Then we are going to talk about bivariate analysis. The way name is suggesting, bi is 2 and variate means variable. So let's first first time we are going to talk about the bivariate analysis. I would say it is not exactly the first time. We had certain discussion. So in bivariate, your first process comes is correlation, wherein we try to understand that how two variables are behaving with respect to each other, like height and weight. What is the relationship between height and weight? Used to compare two quantitative variables. Be careful, this is only on the quantitative. That means on the numbers only. Got it? Second is saying that interpretation methods like scatter plot. We discuss about the scatter plot, wherein it is plotted between two. If you remember your MPG and this number of gears, this displacement, we plotted some scatter plot, and that looks like in x and y axis you get some dots in between. Some dots come. That is what the scatter plot is. Then coming to contingency table. So I will tell you that how do the contingency table look like. Just a moment. This is called contingency contingency, GENCY, contingency table. Let's say that in this class, I'm just giving example of this class, that we have male and we have female, and I am saying coming from technology background, technology background, and second is non-technology background. Okay. So I can easily have, let's say that in this class there are 20 people. Out of that, let's say there are 14 are male and 6 are female. Okay, and out of these 14, 10 male are coming from technology background and 4 males are not coming from technology background. Wherein from the female, let's say that 3 females are coming from technology background and 3 females are not coming from technology background. Got it. And now here I am saying total, and in the bottom also I can write total, and I am saying is equal to sum let's say that in class there are 20 people. So did you see that what I do here? The way I formulate everything, this is called contingency table. Getting it? Wherein we put something in row and column. It's a tabulation. The way it is saying table, it's a tabulation wherein we put something in rows and column. One thing here is to remember that your row is also a category. I'm saying this variable is a categorical, and technology or non-technology, this is also a categorical. Got it? I hope this is clear to everyone. Is there any question? Guys, am I audible? Can you hear me? Am I audible?
Oh, yes, Chinmay, you are audible.
No.
If the thing like, sir, we could not able to distinguish like this way, like 40 members are there. If they are non-technical, technical, like same data, if you are not getting the thing means,
What
you are not able to distinguish the things.
Did you understand here what the example I set and I wrote some random numbers?
Yeah.
This you understand? This is what, if your data is coming in this way, this is called contingency table.
Okay.
I hope
So basically
yeah, tell me.
Basically in contingency table there should be 2 categorical variables.
Yes.
Or can it be 1 categorical and 1 numerical?
If it is 1 categorical, 1 numeric, so like that, in that case it won't be the contingency table.
Okay.
Getting it? It is required that contingency table must have, there may be scenario wherein 1 categorical is there, like you are getting a data only male data. This line is only given. Like let's say that someone is giving this information only.
Okay.
That is also called contingency table. We can call it because you have only the male data. You do not have the female data.
Okay.
Now, this is called the contingency table. And if you remember, in past when we plotted some graph, like wherein I'm just giving the context. If you remember, well and good, you must have seen some graph came like this. Do you remember some graph was plotted like this way? If I merge it up, yeah. Wherein on the empty cards, I plotted something like this. You remember it?
Yeah.
So that is what?
The types of VS.
Yes, VS versus.
Types of VS. Right.
Yeah, with the cylinders and all. So if you are plotting like this, that is itself indicator that's a contingency table. Like the way I mentioned, this may be a male, this may be a female. Okay, and I'm saying that yellow is going to be technology, and red is going to be non-technology. Got it? So this is how even you get graph like this, that itself is indicator that you got something in the contingency table form. I hope that is fine. This is what
VSMI.
This is what we call contingency table. Now, then I'm going back to slide. Now, so correlation and scatter plot contingency table with it. Now coming to t-test and f-test. So remember when I was talking about g-test, g value, I said that g is calculated like x minus x bar divided by standard deviation. That's how z value is calculated. If you remember the formula.
It's standard deviation into square root of n, right?
Standard deviation into
square root of n, right?
So that was, you people forget. this is the formula to calculate the z value. Got it? Wherein we take the x minus x bar and divide with the standard deviation. Okay. Now under root n, that came in different context. That was different context. But this is how the z value is calculated. Let me go back to the slide. I think it seems. Wait. So that formula is applied when you are talking about this one. This formula is applied when we try to find something by help of some given information. So you're talking about this formula that we divide with under root of n. Okay. This is the way when we try to test the hypothesis, wherein sample size etc. that is given. But in general, if you talk about the z equation, okay.
Okay.
So I will showcase. You will be getting the Z value formula. So the one which I wrote, that is, are you getting it? That's what I wrote here.
Yes, sir. Okay.
X minus X bar or mean divided by the standard deviation. That's how we calculate.
Observed value.
Yeah, that is how we calculate Z in the normal scenarios. So when a sample information is given, then we divide that by under root of n.
Okay.
Got it? So we need to remember
So
that
this is the generalized formula, right?
this is
This
the
is the generalized formula
right.
for the population.
Right. This is the generalized formula for population. Got it?
Got it, sir. Okay, thank you.
Now, then I'm coming to Excel. That's what I wrote. X minus X bar divided by the standard deviation. Okay. If I say that standard deviation is, so let me do slide change. So at the place of X bar, I am saying mu. And at the standard deviation, I'm saying standard deviation of population. Got it? This is what your Z is. If I copy the same and write here, and at the place of Z, if I say T, then I will be saying X minus X bar divided by the standard deviation of sample. Got it? That is the difference between Z and T is. So T is done on sample, wherein Z is done on the population. That is clear?
Yes, sir. Yeah.
Now that is a general understanding. Okay. There is another layer which I am going to add. So this is, if someone says, so I'm giving this all into inferences for the technical perspective. Then there is second criteria, and that is called a constraint. What the constraint we have? It says that we use Z if SD of population is known. That is one condition. And second, record size, you can call it sample size as well. Sample size is greater equal to 30. So that is the other condition. So the moment I am saying here standard deviation of the population and sample, it is good to say only the standard deviation. Got it? Because we know that if the standard deviation of population is given, then only we use the Z value. So the standard deviation which is coming at the bottom, that is the standard deviation of population only. Clear? Is this concept clear?
Yes, sir. Yeah.
Now, if any of these two conditions are not satisfied, then we use T, else T. If any of one condition is not satisfied. So Z distribution can only be used when both the conditions are satisfied. The one which I highlighted here. That is clear?
Yes, Chairman.
Now, then your slide is talking about, let me go back to, it is talking about t-test. That's what I explained. That's how t-test comes from the z-test. Next is talking about f-test. You remember in ANOVA we use f-test, f-value, f-table?
Yeah.
This table. This table. Got it?
Yeah.
This is what the F distribution is. Okay. So next is saying that we use t-test or f-test the moment we talk about the bivariate analysis. Now, then coming the chi-square test. Okay. If you remember, the context in which we discuss about the f-test, context is already here. So we have three groups, and for those all three groups, we have some numbers. Got it? So we had three groups, and for all these three groups, we had some numbers. In that case, we use the F distribution. So these are all numbers. So be careful, T and F, these are always used when your values are given in numeric form, numbers. Like sample A, what is the average mean? Sample B, what is the average mean? Sample C, what is the average mean? Then you can run ANOVA, or if you take only two, sample A and sample B. So in that case, you can run Z test or you can run T test to differentiate. Got it? Now, if I go back to this scenario, contingency table, wherein your values are variables row and columns are category, and for those categories you are counting the frequency. These numbers which I wrote, these are the frequency only? Yes or no? If I talk about this number 10, so this 10 is frequency. It is saying that how many mail are coming from technology background. Got it?
Yeah.
This is only frequency. Unlike the previous example, wherein here I'm saying this is the salary of first person, salary of second person, salary of the third person. So this is number, wherein this is a continuous number, wherein this is a frequency. What is written in the contingency table. So be careful, whenever we have rows and columns are the categorical variable, and for those categorical variables we calculate the frequency. There is a different technique in statistics that is called chi-square. What the fourth is given, chi-square. So chi-square help us to deal or answer those questions wherein rows and columns both are the categorical variable.
Shima, your voice is low.
Now, is it audible?
Little bit.
What about the others?
Now it is fine.
Correct, sir. Yeah. It is fine.
Okay.
It's fine.
Now, so what I was saying that whenever you find that your row and columns, both the variables are categorical, in that case, there is a separate statistical method that is called chi-square. So chi-square is useful when your data is having contingency table scenario. Clear?
Yeah.
We'll talk about chi-square. Going forward, we'll talk about the chi-square. No, now the chi-square has come. So I will explain you about the chi-square. It is right time to talk about the chi-square before I move to the other slide. And that example will be very interesting and very humorous. Oh, wait, let me find my.
So when we test, sir, I had a doubt.
Yeah, tell me.
When we test a particular contingency table,
right?
Then we use the chi-square effect.
Yes, you will be getting this example. This example will give you a very clear picture. Okay. It is saying that in office there are 100 employees, and these 100 employees consist of male and female. Okay. You are doing a study to understand that who all deposit their chocolate, biscuit, wrappers into the dustbin, and who all just throw here and there. Got it? So you are going to do this study on 100 people. Out of these 100 people, 25 are female, wherein my cursor is, and 75 are males. Got it? That's what your office construct is. Out of these 25 female, 18 female deposit their garbage into the garbage box. 7 female just litters. Litters means throw here and there, making dirty something. So out of 25 female, 7 female litters. Out of 75 male, 42 male deposit in the garbage box, 33 male simply litters. That means if you look at the entire set of the data, you have 100 respondents. Out of those 100 respondents, 60 respondents deposit where the 40 respondent litters. That's what the data is given to you. That is clear?
Yeah.
Now,
Yes, Shimon.
now, this is the problem statement. That's what I explained in the previous Excel, that your rows and columns both are categorical variable, and in between we get the frequency. Clear? I hope this problem statement is clear to everyone. Now, then you are going to test that your problem statement is that are the littering behavior of male and female are similar, or both are behaving differently. That's what you are going to test. So your null hypothesis is that male and female both are littering in the same way. That means they are throwing garbage here and there in the same way. Alternative hypothesis is no, both are not behaving in same way. At least that means one gender is behaving different than the other gender. I hope that is clear. Am I audible?
Yes, Shimon.
No. So this is the problem statement given to us. And here our null hypothesis is, null means no, no hypothesis is that there is no difference between the littering behavior of male and female. Got it? Wherein the alternative hypothesis is no, male and females are behaving differently.
On what basis we are saying that someone will deposit, someone will litter the things?
It is actual data. We are going to the desk. We are getting that who all are putting the cups on the desk, who all throw into the dustbin. Let's say someone collected data and given to you. Like here in this class, if I observe that who all always keep the mic on and who all mute once they do not want to say, and I'm going to split that on the basis of male and female. I can easily create similar table that in males, how many are putting their mic on, how many are doing the proper adjustment. I can do that. Similarly, it's information which is collected.
And this is not an
one more example. Then there one more example like in a bank deposit versus loan. Males and females deposit versus loan. That can be also.
So that is no, don't move to that part because that will add some more complexity. Okay.
Oh.
The other would be that while who all follow the traffic signal, who all jump the traffic signal. So let's say that you have 25, or give another example. Forget about the liter. That you are standing on a red light, and let's say in an hour time, 100 passenger passed from there. Out of that, 75 are male driver and 25 are the female drivers. Out of 75 male drivers, 42 male drivers follow the traffic rules, 33 just jump. Out of 25 female drivers, 18 follow the traffic rules, 7 simply jump. You can think in that way also. Clear?
So we are understanding here. We are not going to solve anything like deposit and later. We are understanding that this type of people around, like in a company, 100 people are like this way.
Correct.
They are not solving anything here.
Yes, we have this data. Someone gave me this data saying that in this office there are 100 people, 25 are male, 25 are female, and this is how their behavior is. Okay. Can you tell me that male and female both are behaving in same way, or male is making more liters with respect to female?
Correct.
Got it? That's what you are trying to understand.
Okay.
The traffic scenario.
So it is
Yeah.
like it is like in your bank, few are able to repay the loan, few are not able to repay the loan.
That will, you can think in that way. Yes.
Yeah.
Now I hope this problem statement is clear.
Yeah. Yes.
Okay. Now we are going to do some calculations, and I will try to do this calculation quickly. So female, male, then coming male, then the first, let me do one thing. Then is saying deposit, and later, and 18, 7, 42, 33. Okay, and that is what? Okay, and then we are saying total. This is what the data is. Now, so be careful. What all is given here? This is called observed. So number which are given, these are observed. Got it? Now we need to calculate something called expected. Fine. I will tell you how the expected is calculated. In your data, what is the percentage of deposit? 60% is the people they are depositing. 40% people are not depositing. Got it? In the
Yes.
overall 60% people are depositing, 40% people are not depositing. Okay. I have 25 female. If I split in the similar ratio, that means I'm going to calculate 60% of the 25. That means if I say that 60% multiply 25, this will give me the number that what is the 60% of this 25 is, because in my entire data, if 60% people are depositing, so if I calculate for female that what is the 60% for the female, I will get a number. Did you see what I did? I simply calculated what is the 60% of 25. And then I'm calculating what is the 40% of 25. Similarly, I am calculating what is the 60% of 75? And what is the 40% of 75? If I sum it up, still I will get 100. Look here. So, did you get how this calculation happened?
That is a percentage on each this one.
I hope it is clear to everyone. So, if
Yes. Yes.
I write the simply in the formula here, for those who are not able to understand, got it? You can refer this formula as well. That look how this formula is working. Now, this is what the numbers are. So I say that this 15 is coming from this one. This 10 is coming from, I'm going to use different lines because I know people have very big concerns. And this 45 is coming from this one. And this 30 is coming from the next one. So now in case you have any confusion, you can refer those. I did the color coding accordingly. Got it? And now it is 12:30. Let's have a break of 15 minutes. Those who have any confusion, I would suggest this screen is up. Spend some time and look how this is happening. It is very easy, but still, different people have different grasping power. So we'll be coming back at 12:45. Correct?
Okay. Okay.
Hi all.
Hello, sir.
Hi. So can you ping in the chat? I just wanted to know how many people has come back. Simply say yes.
Yeah, already started.
So those who ping
Yes, yes,
previously,
yes. It is.
it's done. Okay, fine. Now we have good number, so we are good to start. So I hope this calculation is clear to everyone. Is it clear to everyone? Anyone who has any question, any doubt? Imtiaz, it is clear to you? Are you there, Imtiaz?
Sir. Yes, sir.
Clear? Clear? Okay.
Sir, 60 of 25 means like, and as I have a small doubt on this. Like I was thinking about that only. Like what we are going to do in this, like 60 of 25 means.
The way I calculated, did you understand this calculation in a logic that how I am doing it? Is the logic clear to you that how it is happening?
Yeah, logic I clear actually. Logic like clearly understood because you have written everything. I understand that.
Right. Now this is
What
what
is
the way I calculated. This is called expected frequency. Right. So the formula for expectation calculation is done in this way. Clear? Wherein
expected value?
Yes, expected value is how it's calculated for all the four cells which are given here, like 18, 7, 42, and 33. For those, how the expected value is calculated.
Okay.
Now, remember these numbers 10, 15, 10, 45, 33, and see what is happening in the next slide. If you look here in the red color, the same numbers are written. So black is what coming from data and red is what we just calculated. I hope that is clear.
Yes.
Now once that is done, then we calculate a new thing. How it is calculated? Actual minus predicted. It is calculated like actual. I'm getting Pooja. Can you mute your mic? I'm getting a lot of background noise. Pooja, can you hear me? Yes. And look at how this calculation is happening. We are calculating, taking the difference of actual minus predicted. Here, 18 minus 15, square it up and dividing with the expected one. This is another task which we are going to do. For each and every cell, what we do, we take the difference of actual and predicted, square it up, and divide it with the expected. Sorry, take the difference of actual and expected, square it up, and then divide it with the expected value. I hope that is fine. Just go through the calculations.
Yes, it is fine.
I hope it is clear to everyone that what is happening.
Yes.
Now, then we are summing it up and getting this value. Got it? This is what the chi-square value is. Got it? So chi-square is written in this way, formula. People say that O minus E, O is observed and E is expected. We square it up and divide by the expected. Clear?
Yeah, clear.
Now, be careful. There is another thing that we are going to do. We calculate number of rows and number of columns, except total. Do not consider total. Without total, how many rows are there? There are 2 rows and there are 2 columns.
Yes.
Now, that these 2 row, 2 columns you need to remember. Then what happens in the next instance? This is how the chi-square table look like. If you look the table, and this chi-square table walk on something called degree of freedom. So if you see the row index, that is called degree of freedom.
Yes.
And how the degree of freedom is calculated? Row minus 1 multiply column minus 1. So in our data, we need to figure out how many rows are there and how many columns are there. So there are 2 rows and 2 columns. Got it?
Yes.
So 2 minus 1 multiply 2 minus 1. That is 1 multiply 1. It means 1.
Yes.
Now, so we need to find in the degree of freedom, 1 degree of freedom. Okay. And if it is not saying anything, if your problem statement is not saying anything, so in that case, we talk about 95% of the confidence. 95. Got it? And 95% of the confidence means 5% of the significance. Look here. That means we are going to look in this column with corresponding to 5%. Got it? So in this table, multiple confidence are given. We are looking at 5% of the significance. That means 95% of the confidence. This is what the value is coming. I hope that is clear.
Yeah.
Now, look at the 5% significance. What is the value coming from the table? The value is coming like 3.84.
Yeah.
Got it? Wherein the one which we calculated in the previous, that is 2. So if I plot on the axis and I say that this vertical line is 3.84, then my 2 will come at this red spot.
Yeah.
Look here, this yellow area is my rejection region. If my red spot is going to fall in yellow area, then that falls under the rejection. Clear?
Yeah.
That means.
So is it by default 95%?
By default, if until and unless it is not stated in the problem statement, we need to consider at 95%.
So if they stated as 99%, then it is 0.01, right?
Yes, 0.01. Got it?
Yeah.
Now, so my red spot is not falling under the yellow region, and the yellow region is my rejection region. Fine. That means the white region is my non-rejection region. That means we fail to reject null hypothesis. And what is my null hypothesis? That the littering behavior of male and female both are same, both are behaving in same way. Got it? So here we are saying that there is no difference in the littering behavior of male and female. Both are doing litters in the similar way. Clear?
Yeah.
This is what the chi-square is. Got it? And I hope this entire calculation, entire explanation is clear to everyone.
Sir, how to look into like tables, sir? I had some doubts in table, how to look the value.
Now, in the table, I suggested that you need to first check the degree of freedom.
Okay, that I got it.
Like row -1 multiply column -1. Got it?
Okay,
So we got
okay,
1.
yeah,
2 minus 1 multiply 2 minus 1, that is 1. So we are in the degree of freedom, we are looking for 1. Clear?
yeah,
Then, depending on the problem statement, are we looking at 95% or we are looking at 99%? So accordingly, we are looking at the column. That in which column should I look for?
okay.
Chinmay, with the help of chi-square, we are accepting the failing to reject the null hypothesis, right?
Yes, we
That
fail
is
to
why
reject.
we use it.
Yes, so we fail to reject the null.
So that is the function of this chi-square test.
Correct.
To
This is
help,
chi.
to help us found this.
This is chi.
Acha, chi-square test.
Yes. Chi.
Okay.
Clear? This is the easiest explanation of the chi-square, and I hope you all are understanding.
Sir, what is the meaning of expected value? Means we are expecting something out of the given question.
So that is the hypothetical expectations, which says that for chi-square we need to have the actual value and expected value, and it is defined that how the expected value is calculated. Clear?
Come again, sir. Please, 1 second. You tell me again.
I'm saying that it is defined in the chi-square derivation that. Wait, my mic has come out. Just a moment. Now, am I audible?
Disturbance is there.
Yeah, sir, audible, sir.
Okay.
So, in the chi-square derivation, it is defined that how the expected value is calculated. So, we need to understand for each and every formula, there are certain derivations, certain processes. So, in chi-square, the way this derivation works, it says that we need to calculate expected value, and the expected value is calculated the way I did it.
Is there any particular meaning for expected value? Means
It only
the calculation wise I understood.
Expected value only says that what is the difference between what is coming from your data and what is the theoretical explanation of the data. So expected value has no meaning. It is only a way to calculate it.
Is this expected value is a practical wise or theoretical value? We are calculating something.
Theoretical.
Is this a theoretical value?
Yes.
So final output will be this chi-square test plot, whatever you are shown in this one.
Right.
Degree of freedom, we are getting output. This is the main output. This is the practical one.
Right.
And sir, what is the difference? Like how we are differentiating this this square test and hypothesis?
So what is your question, Tiaz? I fail to understand.
So is there any difference between the chi-square test and the hypothesis? Like what we are doing in this
hypothesis is a statement which we try to prove, and for that we use chi-square process. Okay. I hope that is clear. Is that clear?
Clear.
Okay. Now, from chi-square, we are moving to, that's what the fundamental understanding for it is given. That's how the chi-square work, or how the chi-square operates. Now, then coming to correlation. So there is one measure that talks about the correlation. Got it? So, do you have idea about the correlation? Anyone heard about this term? Correlation?
Yes, it is the
Yes.
relation between two variables,
Okay.
two independent variables. It's a relation between variables.
All right. Anything else?
Like we have types of correlations like positive correlation, negative correlation, no correlation, perfectly negative, perfectly positive. We have graphs,
Those
statistics.
are certain, what I say, these are certain understanding that we have that how it works. So chi-square, correlation is something which helps us to know that how things are correlated, how things are related to each other. Got it? And look here, there is one formula given. It is saying that the correlation, this term is known as rho, RHO. So the name for this is rho, RHO, rho. So how this rho is calculated? It is saying that it is calculated by taking the covariance of x and y divided by the standard deviation of x and y. So let's say that you have two variables. One is age and second is, let's say, weight. And you are trying to know that what is relationship between age and weight. So in that case, we calculate this correlation coefficient that is given by rho. And be careful, the way this formula is happening, I will rewrite the formula. Let's say that I have age and I have weight. So I am saying age as, let's say, x, and I'm saying weight as y. Got it? So we have two variables, and we are going to understand that is there any relationship between x and y. Got it? So according to statistics, rho, that is RHO, rho is calculated as covariance of x and y, covariance of x and y divided by standard deviation of x and standard deviation of y. That's what theory says. Okay, this is SD. Now, first understand that what is the meaning of this covariance. So, covariance is calculated as the way. Do you remember the formula for variance? How the variance is calculated? Anyone can? Yeah.
X minus x bar by n.
X minus x bar divided by, we square it up first of all.
Yeah, whole square by n.
We square it up and then divided by, I'm saying n.
The number of observations.
Yes, number of observations. That's what we do. I hope this is clear to everyone. Is there anyone who find this challenging? Now, this is how the variance is calculated. Got it? When I write this, I'm saying x minus x bar, square it up. Your covariance is calculated like x minus x bar multiply y minus y bar, and then we divide by n. Okay, this is how your, and again the entire this process happen. Yes, this is how the covariance is. So it says that you consider two variables and then you take it up. I hope that is clear to everyone.
Whole square is not applicable here.
No, because the moment we are doing multiplication of 2x minus x bar, y minus y bar, in that case, whole square is not required. I hope that is fine. I hope it is clear to everyone.
What is the
Yeah, it's
second
clear.
variance here?
What is the?
Like you calculated this, you showed the formula of x minus x bar, right?
Right.
X minus x bar into y minus y bar by n.
Right.
So what is the term basically?
This is called covariance. Got it?
Okay. Okay,
And,
got it.
and then if we divide these two terms by the, let's say, standard deviation of x, standard deviation of x, and standard deviation of y, if we do in that way, then it becomes your rho. So look here, I'm saying the covariance of x and y divided by standard deviation of x and standard deviation of y. Clear?
In covariance, denominator is n minus 1. You can slide it is same.
Can you say once again? Yes, if you can write n minus 1 if you are talking about the sample. So it is your call. So one question is that if I'm saying n minus 1, or you can say n minus 1. It is your call. It depends that you are doing on sample or you're doing on population. Clear?
Yes.
Now, then I am moving to, this is what it's saying. So we need to remember this is how the correlation is calculated. And there is one typical behavior of this correlation, that the value of this rho fall between -1 to +1. That we need to remember as a thumb rule. Got it?
Yeah, yes.
So that we need to remember. Now, next we are going to visualize. Let's say that you have many variables and you are going to plot that in this way. Fine. So it is saying that the moment you plot between many variables, this is how the correlation we get. In earlier case, I said that, let me go to the Excel. Let's say that I have three variables: age, weight, and height. Got it? 3 variables I have. And I want to calculate correlation. That how age, weights, and height are correlated to each other. Got it? So in that case, the way we present that in a mathematical way, okay, we write in this way. Okay, let's say that age and weights are highly correlated. First of all, the correlation between age and age always comes 1 because I am 100% correlated with myself. So all your diagonal comes 1. Because if you look at the diagonals, this diagonal is talking about the height and weight. This diagonal is talking about the height and height. I hope that is clear.
Yes.
Now, then if your weight is, let's say, height and weight is highly correlated, let's say 0.86, and age and weight is correlated 0.7, let's say 93. Then can you tell me that if that is the case, and I'm saying that weight and height is correlated, let's say 0.74. I am expecting you people to fill this colored cell. Can you tell me that what should number first talk
it
about
should be
this?
negative, no, sir. Should be less than 0.
Okay, that will be negative, positive, that could be anything. Got it? I just put a positive number. Okay, you can put anything, negative, positive, because I said that it falls between -1 to +1, so that value could be anything. I just put all positive. Now
So again, the weight and age will be 0.86.
Weight and age will be perfect, 0.86. What about the yellow?
And height and age 0.93.
Okay. What about this one?
Height 0.74.
0.74. I hope everyone understood that how it is happening.
Yeah.
It is clear to
Yes.
everyone. Now, if I plot it in the graph, this is how your graph look like. Look here. If you're plotting, are you getting that what all written in the row, the same is written in the column as well? You can see here, in this case, it is written at the bottom. So look, your passenger ID is your first column. Survived is your second column. You getting it? It is the same information written in that way. Are you getting it is conveying the same message?
Yes, sir.
Perfect. Look here. This is saying something about the relationship between temperature and ice cream. Ice cream sales versus temperature. Can you tell me something about this? That what is your understanding by looking at this graph? Can you say something?
So whenever temperature is increased, ice cream sale also it is going to be increased.
I hope that is clear to everyone. So see here, whenever temperature is increasing, your ice cream sale is increasing. I hope to the rest of the class it is clear.
Yeah, sir. They are clear.
Okay. Then look here, there are 3 graphs. Can someone tell me that what you mean by these 3 graphs? Go through.
So when the temperature is increasing, sales are increasing. When there is no change in temperature, the sales are flat. And when the temperature is decreasing, the sales are decreasing. I don't know. I'm not sure.
There are 3 graphs. Okay. The first graph is saying that whenever your X is increasing, your Y is also increasing. Ice cream.
Linearly proportional.
Right? This relationship is called positive relationship, because your X is increasing, your Y is also increasing. Got it?
Yes.
What about the second one?
If temperature is constant.
There's no change between Y and X. It's
Yes.
the same.
Whatever X is happening, Y has no impact.
Yeah.
Like sale of sugar or sale of salt. If you increase the price whatever, or you decrease the price whatever, do you think that in market, if offer is coming on a salt that buy 1 packet and get 10 packet free, we will start consuming salt double? Do you think so? That won't happen. Clear?
Yeah.
Yeah.
Now, look at the third graph and tell me your understanding.
It's inversely proportional.
Yes.
So what do you mean by that?
If temperature decreases, I stimulate decreases.
X is decreasing with respect to Y.
Okay.
And both variables are dependent.
Okay, so what do you mean by that?
The relationship between the both should be a similar, a dependent. It is not independent. It is not dependent in sense. See, if, for example, if the rate of bike increases, the rate of petrol also increases. It is dependent, like bike and petrol, diesel and for the how we dependent. So independent means relationship between petrol and diesel is independent.
Okay, what else?
Let's see, the 1 liter milk rate increases, the third rate also increases. The relationship between milk products.
Okay.
Yeah.
What others are thinking?
Same, sir. X does not depend upon the Y. So, and in this ice cream means it does not depend upon the climate. It will be parallel.
So here it is saying that if your X is increasing, your Y is decreasing.
It means behavior of X is dependent on behavior of Y.
Both are correlated. It is there. But can you give one example wherein one is increasing and other is decreasing?
Yeah, but it's inversely proportional, like
Yeah. Can you give some example? There are many examples. If you think, you will come to know some examples.
It is a workout. If we do the workout and reduce the weight.
More workout, less weight. That's what we're saying.
Yeah.
Fuel versus mileage. Fuel versus mileage.
For
more mileage, more miles it runs, more distance, the less fuel it's gonna come down.
I have a slightly different opinion. Mileage versus weight of car. Getting it? If the weight of the car
It's there.
increases, mileage decrease. Getting it? Or power versus mileage of the car. More powerful cars gives less mileage. Clear?
Yeah.
Now, this is a data which is called the cross tabulation. You remember that's what I explained about the cross tabulations, that you have something in rows and something in column. And accordingly, you prepare this table, which is known as contingency table. Clear? This is cross tabulation. First, we do the cross tabulation. And the moment you do the cross tabulation, it is known as contingency table. I hope that is fine.
Fine.
Okay. Now, then coming to hypothesis testing. We all know about null hypothesis, alternative hypothesis. So look here, null hypothesis is given as H0, wherein alternative hypothesis is given as H1. Clear?
So your voice was breaking actually. It wasn't clear.
Now, is it clear?
Yes, Chinmay, your voice was, I think, broken. Yeah. Now it is clear. So when you're saying something, so the time it is not clear actually.
So, okay. So just a moment. Give me a moment. Let me change to other Wi-Fi. Now, I hope you people can hear me properly.
Yeah, now we can.
Okay, perfect. So here, something about null hypothesis and alternative hypothesis is given. That's what we discussed in the previous class. So do you find here anything which is new for you, which you do not know? So something is, your hypothesis is the statement about the population such that it is either true or false. That's what we discussed about the hypothesis?
Yes.
Perfect. Now, then we discuss about null hypothesis and alternative hypothesis. Just go through, try to understand what is written here. I hope this is fine.
Yes, it is.
Then this is how, you remember I explained about equality, inequality. So when we are talking about a two-tailed test, your hypothesis is written in terms of equal to sign or not equal to. But when it is coming to one tail or two tail, it is written in terms of less than or greater than. That is how indicator that you are working on one tail or you are working on two tail. Clear?
Sir, here the left side is one-tailed test, right?
No, the first is, it's not left right. The first line is two-tail test. Second line and third line are one-tail test.
Okay.
So in the left side, it is written null hypothesis. In the right side, it is writing alternative hypothesis. Got it? I hope that is clear.
Yes.
Now, then I explain about type 1 error, type 2 error. Just go through. So this section is primarily the revision of what all we discussed in the previous class. Just go through. Some write-up is given for type 1 and type 2 error. I explained about alpha, beta. So those all terms are coming here.
Sir, if we go through the example what you had like mentioned in that particular type 1, type 2 error class,
Mm-hmm.
can come to know, but while reading this lines, we are a bit confused.
Okay. So that is perfect. So the example which I suggested,
You explained some
yes, I said
the
that.
candidate versus the
Yes, I said that actual, and you can say predicted or observed. That is better name. So actual candidate is good candidate, and
bad
here
candidate.
bad candidate, and here good candidate, and here bad candidate. Okay, and we are talking about these 4 cells. So I'm calling it A, I'm calling it B, I'm calling it C, and I'm calling it D. Got it?
Okay.
These two are wrong. These two are false.
Yeah, those two are false.
Got it? Look here.
Yeah.
Actually, a candidate is good, but I'm saying the candidate is bad. So I'm putting that in yellow color. Got it? But actually, a candidate is bad, and I'm saying good. This is what I say about the yellow one is type 1 error.
Yeah, type 1 error.
And this is the red one is type 2 error.
In which the type 2 error has more prominence, right?
It is more problematic.
So in this example, sir, if we analyze like this, we'll come to know which one is type 1, which one is type 2. But while going through the what do you say, the slides, it is a bit confusing.
Okay, now that was the reason that those quadrant I explained first, and then we land to this place. Now I hope this is clear.
Yes, sir. Yeah.
Then talking about the decision. Okay, you consider my scenario. What is done here? Here, the matrix is reverse. Innocent, guilty. Fine. And if something is someone is innocent and he is given prison, someone is guilty and he is set free, So it is saying that I would suggest that this is something which is on the qualitative part. It is good that you refer my Excel, because here your quadrant is reverse. What should come in row, that is coming in column. So it is good that you follow my part. Clear? Look here, innocent is given present. It is saying type 1 error, but a guilty is set free. That is very problem. Get it? Both are wrong.
Yeah.
Got it?
Yeah.
Now, in hypothesis testing, we have multiple stages. Just go through. These are the 5 steps or stages we discussed in previous class as well, wherein I was explaining this entire stuff.
Yes.
The
Now,
first step in the last slide.
yeah, just a moment. Talking about this one?
Yeah, in this slide, in this particular slide. Now, in the third step, that is mentioned as identify the test statistics. Right? That is to calculate the value of Z.
Correct.
Calculate the value of Z through the formula.
Right.
And p-value or table values in which we compare, we get the value through the table, that particular table, whether it is t-test or z-test, it depends on the condition, right?
Right.
If it is a population, then we go with z-test. If we take the sample, then we go with the t-test. Then after that, interpretation is when we will come to know whether it is we reject null hypothesis or we fail to reject null hypothesis.
Correct.
In the fifth. So I just wanted to clarify.
Yes, that is the process.
Okay.
Got it?
Got it. And in the second step, that is the alpha value, right?
That's a yes. So it's saying that select the level of significance. That what is the alpha you are going to have. Correct.
That is of type 1 error. Type 1 error.
Yes. Clear?
Yeah, clear, sir. Yeah.
This is the tabular information. The same was there in our previous discussion as well, but go through. It is what all we saw in the steps, like step 1, 2, 3, 4, 5. It is written in the tabular form. Go through, try to understand it. That is fine. I hope it is clear to everyone.
What is the meaning of the?
Tell me.
like in the green box, they are mentioned to determine the critical value of these statistics. I didn't understand, sir.
This
I didn't
is
understand that particular.
determine the critical value. Fine. So your critical value is the one which is coming from the table. So what all you are getting from the table, that is what the it's saying that calculate the test statistics and then determine the critical value of the t statistics. That is what you are getting from the table. And then you are comparing that is your table value is similar to what all you are calculated to that way, or it is something else.
Okay.
Clear?
Determine the probability value means that is same, right? So how much probability it has they are giving percentage?
Right.
It's a 0.5 or
Right.
yeah.
I hope now it is clear to everyone. Is there any question, any concerns which you have? I hope this part is clear. Any question, guys? Anyone have? Okay. If there is no question, then look at this. It's saying that one tail hypothesis testing and two tail hypothesis testing. So look here in the left side, it is talking about inequality, that is less than greater than, where in the right side it is talking about equality. So go through the statement, what all is given here. I hope this is, you need to figure out that what it's saying.
Here in one tail test, H naught value is mu is equal to mu naught, right?
Can you repeat once again?
In one tail test, sir,
Uh-huh.
the left side of the slide, they have mentioned H naught is mu is not less than or equal to mu naught.
Correct.
But it should be mu is equal to mu naught, right?
No, it's equal to is coming right side. So right side is two tail test.
Okay.
So the moment you are talking about equal to, it is you are making that as a two tail test.
I thought if H naught is mu is equal to mu naught, then H1 is mu less than mu naught, then it would be the tail test. If mu is greater than mu naught, then it would be right tail test, right?
Yes, so here it is saying the one tail test, wherein we are saying that mu is greater than mu naught. That's what the null hypothesis is. The alternative hypothesis is no, mu is less than mu naught. So this is what your one tail test is given. It is simply comparing about the one tail test with respect to two tail test. Like here, look here, if it is written in this way, this is talking about a left tail test. If it's written in this way, that is again talking about the right tail test. Oh, so look here, you can see the symbols are reversed. So it's all depend that your yeah, tell me.
H naught,
like determines the null hypothesis, right?
H naught determines the null hypothesis.
H naught.
Correct.
So, the one-tailed hypothesis is written every value assumed in H1 is on either side of the values assumed in the H1.
You remember the bulb. Yeah, you remember the bulb example. That will give you the clear context. Wherein we are saying that it lasts 10,000 hours. And then we are saying that no, it is not. It is at least 10,000 hours. So the moment statement is coming at least 1,000 hours, then this is how the one-tailed test comes.
But in the two-tailed test also, it is on either side of the values.
In the both side, in that case, it is going both side. In one tail, it is going either rejection is happening in left side or rejection is happening in right side.
So if the value of H1 is in one side, the value of H1 is in the other side.
All right.
Okay.
I hope that is clear.
Sir, in particular, hello.
Tell me.
Sir, in the example what you are given, like if a particular company manufactures about a CFL that lasts for 10,000 hours,
Yeah.
then in that context, in that particular case, we take mu is equal to mu naught, right? That particular statement what I told you, that is mu naught.
Right. So understand how it is taken care. You are saying that there are two scenarios. First of all, you are claiming that your CFL is going to last at least 10,000 hours.
Okay.
Got it? That means your null hypothesis is that the CFL of life is, say, life of the CFL bulb is greater or equal to 10,000 hours.
Okay.
Your alternative hypothesis is no, it is less than 10,000 hours. Got it?
Okay.
So that is
okay.
Yeah, that is going to be your left tail, one tail test.
Okay.
Got it?
Got it, sir.
I hope now it is clear to everyone.
See, it is like the debate, right? Left and right.
It's not debate, it's a problem statement. Where can debate comes? It's a
No, if one is saying, if one is standing for less than, another standing for right than, then it is a concept of debate concept.
Look at this Excel. I'm saying the two statements. Oh, wait. Two statement. The first statement is saying that mean life of CFL is at least 10,000 hours. Sorry, mean, MEAN. Mean life of CFL bulb is 10,000 hours. What does it mean? Can someone explain me that what is meaning of this?
CFL can withstand 10,000 hours.
So minimum 10,000
The
hours.
particular bulb is minimum is 10,000.
It may
Not
be
more than that.
It means minimum 10,000. Yeah, it may be more than 10,000 also.
It may be this one
It's
also.
a tested one that.
It may be 11,000 as well. Correct?
Sir, as per the CFL, they were giving as a 10,000 hours. They have checked. It will withstand to 10,000 hours.
Yeah. So what?
No, they are saying at least.
At least.
Okay.
Got it? So we are saying
Can
this
be
is,
more.
so it may be 11,000 hours as well. Okay. Now, so this is your null hypothesis. So your null hypothesis is saying that your null hypothesis is going to be like the value of CFL is greater or equal to 10,000 hours. Clear? And your alternative hypothesis is going to be alternative hypothesis saying that it is less than 10,000 hours. Got it? So now tell me, if I plot a graph, if I draw a graph here, like in, let's say in this way, so my rejection region will come, let's say that this is, I'm saying this is 10,000. This point is, let's say 10,000. So if anything is falling in this region, that will fall under null hypothesis? Yes or no?
Yes.
Yes.
Anything falling under this region, which will be falling under alternative hypothesis?
Yes.
Yeah, it is a rejection.
This is called one tail test and this is left tail. I'm saying this is left tail. I hope this is clear to everyone.
Yeah.
Now take the another example. Okay, so in another example, I'm first going to plot a graph and then I will say. Now here I am taking the example of Maggie. According to Nestle, okay, that what is it? The saturated fat in each 100 gram is at max 2 milligram. That's what they say. Nestle claim that the saturated fat in their 100 gram pack is at max 2 milligram. Clear? So my null hypothesis in this case is going to be the saturated fat value is equal to or less than 2 milligram. Null hypothesis. What is my alternative hypothesis in this case? Is saying that this value is greater than 2 milligram. Got it? So in that case, anything which is more than 2 milligram, which is going in the rejection. I'm not added my pen pad. That's why I'm feeling difficulty. Did you see that how this is changing? So the way you are saying in this way, your rejection is falling on the right side. So the second example is right tail test. So it is not about debate. It's all about the problem statement, what the problem statement is given.
Sir, our intention is to find the alternate hypothesis.
Yes. We need to find that is the alternative hypothesis is same as the null hypothesis or that is different than the null hypothesis.
So generally null hypothesis will be like assuming, everyone will assume the same thing, like 2 milligram will be there is a saturated fat in the this one, like Maggie packet. So we have to find that alternate hypothesis. Our intention is H1.
And that's what the claim is made by someone. Clear? I hope now that is clear to everyone.
Yeah, yes, clear.
Now, then I'm going back to your slide. I think after this explanation, I hope that you people have clarity. Otherwise, it will be difficult to move forward. That's what it's saying. So look at in case of now at the same time, if you look at the third scenario, two tail test, wherein manufacturer is claiming that the CFL bulb lasts for 10,000 hours. In previous case, I used this term at least, at max. Here, those terms are not used. CFL bulb lasts for 10,000 hours. What does it mean? It means that your 10,000 is here, okay, and you are going to take the 95% confidence, both the sides, getting it, and these sides wherein this arrow mark is coming, these are your rejection region. Got it? So in that case, your null hypothesis is going to be H naught. H naught is going to be 10,000, and H1 is going to be, it is saying that it is not equal to,
equal to 10,000.
Not equal to 10,000. I hope it is clear now.
Yeah.
That's what your slide is saying. Let me erase all the drawings. Yes. Got it?
Yes.
Okay. Now go through this write-up. You will understand that what is the story of this write-up. There are 4 steps. Try to read and understand. I hope that all statements are clear.
So in the fourth statement, the random chance probability is less than 5%. Then we conclude that there is difference in behavior. What giving a tips.
Yes.
If alpha value is less than 5%, then we
reject it. Clear?
I didn't get that fourth statement, sir. Fourth.
If the random chance probability is less than 5%, then we can conclude that there is difference behavior of the 2 different populations. So random chance is the probability that we are calculating. Those are known as random probabilities. Getting it?
Okay.
So saying that if random chance probability is less than 5%, that is less than 0.05, then we conclude there is difference in the behavior of 2 different populations. That means in that case, we reject the null hypothesis.
Sorry, sir.
In that case, we reject the null hypothesis.
Okay.
Littering behavior of male and female. We realize that that value is less than the table alpha at the 5% confidence, 5% significance, sorry. Got it? So we, in that case, we fail to reject.
Okay.
I hope that is clear.
So 2 different population in the sense, like if we consider an example of population of Mumbai and population of Delhi. If it is less than 0.5, then we fail to reject the null hypothesis. Right?
If less than 0.5, then we reject the null hypothesis. So
Yeah,
listen,
we reject the null hypothesis.
if P is low, null will go. That is the phrase. If P is low, null will go.
Okay.
People say go back. That means you're not required. So here the meaning of go is, and in that case, null hypothesis is not valid. In that case, the alternative hypothesis is valid.
Okay.
Got it?
Got it. Got it.
Now, look
So
at
confidence means
confidence
level, last line.
The confidence level, that's what I said that at the 95% label, we do it. So 1 minus significance is confidence. So if your 5% is significance, then 95% is confidence. Clear?
1 minus significance. Okay.
Now, this is, look here, the null hypothesis, alternative hypothesis information is given. Just go through. You will be getting the same context. I hope it is clear.
Yes, it is clear.
Then this is for two side. I said that the CFL life is 10,000 hours. That means we calculate 95% left and right and see that how values are falling. Got it?
Yes, understood. Yeah.
And now, then it is saying something about degree of freedom. We'll talk about degree of freedom in next class. I think we are on the top of the hours for today. Clear?
Yeah.
Fine. So let's close here. We'll see you tomorrow at the same time.
Yeah, sure. Check.
Perfect. Thank you. Thank you, everyone.
Thank you. Thank you.